Alright, two-step equations. Now it's getting to be a little fun. When you have two-step equations like the one here in my example, what you want to do is get rid of the constants first. Then you want to do the multiplication or division. So, for example, I have 2x plus 6 is equal to 12. The constant that I want to get rid of is that positive 6 because I want to get the variable by itself, meaning I want to get rid of everything on the side with the variable. So I'll get rid of that positive 6 by doing a negative 6 on both sides. On the left side, I have 2x remaining, and on the right, positive 12 and negative 6 gives me 6. Now I have a one-step equation to solve. I have 2 times x equals 6. To get rid of the 2, I'm going to divide both sides by 2. X is then equal to 3. My check step, I'll use the original equation. 2 times 3 plus 6 should be equal to 12. 2 times 3 is 6, plus 6 should be equal to 12, and I know that it is, so I am good. Awesome. Let's move on to one that could be a little tricky, though. Right here, this one is tricky for 2 reasons. First, it's tricky because I have that double negative. So the first thing you should do is this. Negative x plus 8 is equal to 2. Alright? Because those 2 negatives right there become a positive. Don't forget that. Now what I want to do is get rid of the plus 8, or that positive 8, by doing a negative 8 on both sides. On the left-hand side, what I'm left with is a negative x. On the right, I have a positive 2 and a negative 8. Give me a negative 6. Here is where you have to be careful, because a lot of students would stop right now, but you can't. Because this right here, that means the opposite of x. I don't want to know what the opposite of x is. I want to know what x is. So how do you get rid of that? Well, remember, this is the same thing as having a negative 1x, which means negative 1 times x. So that means I can get rid of it by dividing by a negative 1. And I do it on both sides. Then they cancel, and x is equal to a positive 6. That is one that many students struggle with. Make sure you understand that. For my check step, I have negative, and then x is 6, plus 8 should be equal to 2. Oh, actually, sorry, I made a mistake myself. I always say use the original equation, and I didn't do it. Sorry. Minus negative 8 should be equal to 2. This is negative 6 plus 8 equal to 2, and 2 equals 2, and it works. Let's go on to my next sample. This one is tricky as well, and it's tricky because of that negative sign out in front of the fraction. Well, what does that mean exactly? Well, a fraction is negative, and it doesn't really matter where the negative is placed. A lot of times where you're going to see it is right there on the fraction bar, but what I want you to notice, I'm going to write 3 different things here that mean the exact same thing. First of all, this, or this. Both, or all 3 of those, are negative fractions, and they all mean the exact same thing. So when you see that, you want to, and you get rid of that 4, you want to make sure to include the negative with it. Otherwise, you're going to have a negative x left over. But let's start first by getting rid of the constant, that 9. I'm going to subtract 9, or do a negative 9 on both sides. And now what I have left here is a negative x over 4 is equal to 9. Remember, I want to get rid of the negative 2. So I'm going to say negative, multiplied by negative 4 on both sides. I guess I shouldn't have said negative 2, negative also. So I want to get rid of that negative also, or as well. So now they cancel, leaving just x. And 9, a positive 9 times negative 4 gives me a negative 36. I'm going to do my check over here. And I have a negative, and x is negative 36 over 4, plus 9 should be equal to 18. Now these 2 negatives cancel each other, so it's just 36 over 4, plus 9 should be equal to 18. 36 divided by 4 is 9. Plus 9 equals 18. 18 equals 18, and it works. Okay? You want to make sure to be careful with these. And notice that my check step was actually longer than us solving the problem. Sometimes that will happen. All right? How about if we try some word problems? Yum, fun, fun, fun. Let's start with a verbal phrase. Verbal phrase is not a whole problem, but it is words that you need to translate into a problem. So here I have twice a number less 10 is 20. You got to look at all the components here and it would make sense. First, twice a number means 2 times some variable. So let's say x. Less 10 means you're subtracting 10. Is means equals, and then 20. So our equation is 2x minus 10 equals 20. And again, you could use the sheet that I gave you to help you find out what all these little keywords mean. And what we'll do is we'll add 10 to both sides to solve this, and we have 2x is equal to 30. Divide by 2 on both, and x is equal to 15. And then you can perform a check if you like. But let's move on to a word problem. Those are more fun. Ooh, this is a biggin'. For the 8th grade Great America trip, each student is given $19 for food. Now, this is just a word problem. You're not actually going to be given money for food next year. This covers the cost of 2 meals at X dollars each, plus $7 worth of snacks. Write a two-step equation to find out how much money the school expects each student will spend per meal. I'd like you to pause the video and try and come up with the equation yourself. So go ahead and pause it now. Okay. Hopefully, when you were looking at this, you said, all right, this is the key information here. $19 for food. That's the total amount. Then I have 2 meals at X dollars each. Plus, there's another key word, $7 worth of snacks. Okay? Now, the thing about word problems, if you go to the very last sentence, you will almost always find what you're solving for. So here, spend per meal. That's what you're actually solving for. So if I were to write a let statement, I would say let X equal the cost per meal, because that's what I really want to find out. So in my problem, I have 2 meals at X dollars each. So we're assuming that they cost the same amount. So I would say 2 times X would be the cost that I would spend on the meals. And then plus, we know that means that, $7 worth of snacks. And our total amount that we have to spend was $19. So now we could solve for X by subtracting 7 from both sides. We have 2X is equal to 12. Divide by 2 on both sides. And X is equal to 6. Now it's a word problem, so you're not done here. You have to give some kind of label, and it's $6. And again, we said per meal is what we were solving for. So $6 per meal. Cool? Let's try another one. Alright, it took Natalie 85 minutes to wash 3 cars. She spent X minutes on each car and 10 minutes putting everything away. Write a two-step equation to find how long it took to wash each car. Okay, so here again, key information. Let's go to the last sentence, right? What are we looking for? Wash each car. So that would be for my let statement. Let X equal the time per car. And then I look for any numbers that I have in the actual problem. And I have 80, whoops, wrong thing. Let me get my highlighter. 85 minutes. Okay, that was the total. And then we have X minutes per car. Great. And 10 minutes putting things away. So there's all the information that we need. So she did 3 cars, and it was X times each, plus the 10 minutes to put everything away would equal the total amount of time that she spent. Now we could solve for X. Subtract 10 from both sides, And you get 3x is equal to 75. And then we could divide by 3 on both sides. Oh, that's a bad 3. X is equal to 25. Now, the answer would be 25 minutes per car. When you look at that, ask yourself, does it make sense? And yes, it does, because 25 minutes per car, she had 3 of them, 10 minutes to put things away, it would work out. Okay, my last one is really interesting. See if you could do this problem yourself. Ethan and David are brothers. If Ethan is 3 years older than David, and the sum of their ages is 17, how old is David? Whew. Pause the video and try that. Okay, this one, what we're trying to solve is right here. How old is David? So that would be my let statement. Let x equal David's age. David's age. Okay? And now, the thing that we don't know is we don't know how old David is. We also don't know how old Ethan is. But we know that Ethan is 3 years older than David. So that's the key. So if we say, all right, well, this is David's age. And then we said Ethan is 3 years older. So the sum of their ages is 17. So here is David. And then Ethan is going to be David plus 3. And this is going to be equal to 17. Now, the parentheses really aren't necessary here, but what I wanted to point out to you that this is David and this is Ethan, okay? So, drop those parentheses. I have x plus 3 is equal to 17. Well, here you have like terms. If you're unfamiliar with this is 1x and here is 1x. If I combine them together, I have 2 of them, or 2x plus 3 equals 17. Subtract 3 from both sides. I have 2x is equal to 14. Divide by 2. And x is equal to 7. So David is 7 years old. And then you see, all right, does it make sense? Well, Ethan is 3 years older. So that means that Ethan is 10. And the sum of their ages is 17. And it works. That is all. Goodbye, my friends.